Pro Football player Travis Kelce is pressed for time during the football season. So he does two things at once. Whether it's grilling while mowing.
Two things at once!
Or getting this season's updated COVID-19 shot at the same visit as his flu shot.
Two things at once.
You can be like Travis and ask your pharmacist about getting this season's COVID-19 shot at the same visit as your flu shot, if you're due for both, as recommended by the CDC. Learn more and schedule at vaxassist.com. Sponsored by Pfizer.
Introducing Carvana Value Tracker, where you can track your car's value over time and learn what's driving it. It might make you excited.
Whoa, didn't know my car was valued this high.
It might make you nervous.
Uh-oh, market's flooded. My car's value just dipped 2.3%.
It might make you optimistic.
Our low mileage is paying off. Our value's up.
And it might make you realistic.
Car prices haven't gone up in a couple weeks. Maybe it's time to sell.
But it will definitely make you an expert on your car's value. Carvana Value Tracker. Visit Carvana.com to start tracking your car's value today.
Hi again, it's Steve here with another episode of Astronomy Daily for the 23rd of October, 2023.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
Well, it's nice to be with you and lovely to have our dynamic digital delight on board again. G'day, Hallie.
Hi, they're human. Happy to hang with you again. I hear you had a celebration this weekend, Grandad.
I sure did. My beautiful granddaughter Nora hit her second birthday milestone and we travelled from Newcastle, where I live, to Sydney to celebrate with the family on a very warm Aussie summery day. It was 30 degrees outside, very warm indeed.
That sounds like wonderful fun.
Well, it was great fun to surround Nora with a great big crowd of family and shower her with lovely presents, of course, and all the way to the afternoon when she could hardly stay awake. A big day for a little lovely.
You big softy.
Oh, I know.
Okay. I've got some stories for everyone from the Astronomy Daily newsletter, so shall we get right into it?
Well, you've got the stage, Hallie. I say go for it.
Here are today's short takes. When it comes to the current era of space exploration, one of the most important trends is the way new technologies and processes are lowering the cost of sending crews and payloads to space. This includes NASA, which recently built and tested an aluminum rocket engine nozzle manufactured using their new reactive additive manufacturing for the fourth industrial revolution process, Ramfire, for short. This production process creates virtually no waste and is very rapid, cost-effective, and efficient compared to traditional methods. Whereas it was once confined to modeling and prototyping, the technology's applications have expanded considerably in recent years, including the aerospace industry. The aluminium nozzle was developed by NASA's announcement of collaborative opportunity in partnership with the leading AM company Elementum 3D, based in Erie, Colorado. The company was selected as part of an announcement of collaborative opportunity to create a weldable type of aluminium that is heat-resistant enough to be used in rocket engines, leading to the aluminium variant known as a 6061 Ram2. Compared to other metals, aluminium has a lower density and can enable high-strength, lightweight components. However, with conventional manufacturing, a rocket nozzle may require 1,000 individually joined parts. This makes aluminium impractical since it has a low tolerance to extreme heat and a tendency to crack during welding. The Ramfire process, which was funded under NASA's Space Technology Mission Directorate, does away with this by producing aluminium components as a single piece, requiring far fewer bonds and significantly reduced manufacturing time. In addition, the nozzles are designed with small internal channels that keep the nozzle cool enough to prevent melting. Meanwhile, the Ramfire 3D printer and process were developed by another commercial partner, RPM Innovations. This South Dakota-based company specializes in directed energy deposition, where layers of powdered alloy are deposited and fused by lasers. When combined with Elementum 3D's specialized aluminium powder, the resulting process is known as laser powder-directed energy deposition. Earlier this summer, 2 Ramfire nozzles completed a series of hot fire tests at the Marshall Space Flight Center's East Test Area in Huntsville, Alabama. The nozzles performed well using liquid oxygen and liquid hydrogen, as well as liquid oxygen and liquid methane fuel configurations, and at pressures exceeding 5,690 kilopascals, 825 psi, higher than is anticipated for launches. SpaceX successfully executed a two-part Starlink satellite mission on Saturday, deploying a total of 44 satellites from 2 separate launch sites in a single day. The ambitious mission represents the latest milestone in SpaceX's ongoing effort to expand its Starlink global broadband service. The day's first launch took place at 4:23 a.m. Eastern Time from Vandenberg Space Force Base in California. A Falcon 9 rocket lifted off, carrying 21 Starlink Internet satellites into low Earth orbit. About 8 minutes after launch, the first stage booster landed safely on a platform in the Pacific, marking another successful recovery for SpaceX. The aerospace manufacturing company, owned by billionaire Elon Musk, broadcast the first launch over the Internet, capturing key moments like the liftoff and the dramatic separation of the main booster stage. Approximately an hour into the flight, SpaceX confirmed the successful deployment of the 21 satellites via social media platform X. The evening launch from Florida adds another 23 satellites building on the day's earlier success. SpaceX launched a second Falcon 9 rocket at 10:17 p.m. Eastern Time from Florida's Cape Canaveral Space Force Station. This second rocket carried 23 additional Starlink satellites, marking mission 6-24. Mission Control had planned for 5 backup opportunities for an alternate liftoff, but they were not needed as the launch went ahead as scheduled. The company aims to achieve 100 satellite launches by the end of the current year and has plans for another 144 launches in 2024. Now, an Artemis update. NASA conducted the first hot fire of a new RS-25 test series on October 17, beginning the final round of certification testing ahead of production of an updated set of engines for the SLS, Space Launch System, rocket. The engines will help power future Artemis missions to the Moon and beyond. Operators fired the RS-25 engine for more than 9 minutes, 550 seconds, longer than the 500 seconds engines must fire during an actual mission, on the Fred Haise test stand at NASA's Stennis Space Center, near Bay St. Louis, Mississippi. Operators also fired the engine up to the 111% power level needed during an SLS launch. The hot fire marked the first in a series of 12 tests scheduled to stretch into 2024. The tests are a key step for lead SLS engines contractor Aerojet Rocketdyne, an L3 Harris Technologies company, to produce engines that will help power the SLS rocket, beginning with Artemis V. The test series will collect data on the performance of several new key engine components, including a nozzle, hydraulic actuators, flex ducts, and turbopumps. The components match the design features of those used during the initial certification test series completed at the South Mississippi site in June. Aerojet Rocketdyne is using advanced manufacturing techniques, such as 3D printing, to reduce the cost and time needed to build the new engines. For RS-25 engines help power SLS at launch, including on its Artemis missions to the Moon. The Space Launch System, SLS, is NASA's state-of-the-art rocket system, engineered to carry astronauts and essential payloads on the agency's deep space exploration missions, including trips to the Moon and Mars. As the backbone of NASA's Artemis program, the SLS is designed to evolve into different configurations to meet an array of mission demands, making it the most powerful rocket ever built. Its primary objective is to support NASA's broader goals of re-establishing human lunar presence and eventually sending astronauts to Mars. As a versatile heavy-lift launch vehicle, the SLS will work in tandem with the Orion spacecraft to facilitate these ambitious space exploration endeavors, enhancing the boundaries of human reach in space. A recent study published in Nature Astronomy examines the discovery of what astronomers are dubbing ultrafast radio bursts, a new type of fast radio bursts, FRBs, that the team determined lasts for a mind-boggling 10 millionths of a second or less. Traditionally, FRBs have been found to last only thousandths of a second, but this study builds on a 2021 study that hypothesized FRBs could possibly last for millionths of a second. This also comes after astronomers recently announced the discovery of the oldest and farthest FRB ever observed, approximately 8 billion light-years from Earth. During our group meetings, we often talked about it, said Mark Snelders, who is a PhD candidate at Astron and the University of Amsterdam, the Netherlands, along with being the lead author of the most recent study and a co-author on the 2021 study. By coincidence, I found out that there was a public dataset that we could use for this. For the study, the team was able to obtain 5 hours of data on a known FRB called FRB 201211102A, which was discovered in November 2012 and is located approximately 3 billion light-years from Earth, along with being considered the first known repeating FRB, according to a 2022 study. The data was obtained from the Breakthrough Listen project, which is a worldwide scientific collaboration with the goal of finding evidence of extraterrestrial intelligence, with the data specifically coming from the Breakthrough Listen at Green Bank portion of the Open Data Archive. Upon obtaining the data, the team took the first 30 minutes and split each second into 500,000 separate images, then incorporated machine learning and software filters to isolate outliers within the data to identify 8 ultrafast radio bursts lasting a mere 10 millionths of a second or less. For context, 10 millionths of a second is equivalent to 0.0000001 seconds.
Oh, well, that's easy for you to say, Hallie.
Nah, it was nothing.
Oh, pretty close to it anyway.
You silly man. The researchers note, in detecting and characterizing these microsecond duration bursts, we show that there exists a population of ultrafast radio bursts that current wide-field FRB searches are missing due to insufficient time resolution. These results indicate that FRBs occur more frequently and with greater diversity than initially thought. This could also influence our understanding of energy, wait time, and burst rate distributions. While questions remain as to how these ultrafast radio bursts are produced, the team does expect to identify more ultrafast radio bursts in the future. However, the difficulty lies in finding data files capable of being split into 500,000 separate images per second, as some files lack the necessary specifications to make such splitting possible. And speaking of FRBs, 8 billion years ago, something happened in a distant galaxy that sent an incredibly powerful blast of radio waves hurtling through the universe. It finally arrived at Earth on June 10 last year and, though it lasted less than 1,000th of a second, a radio telescope in Australia managed to pick up the signal. This flash from the cosmos was a fast radio burst, FRB, a little understood phenomenon first discovered in 2007. Astronomers revealed on Thursday that this particular FRB was more powerful and came from much farther away than any previously recorded, having traveled 8 billion light-years from when the universe was less than half its current age. Exactly what causes FRBs has become one of astronomy's great mysteries. There was early speculation that they could be radio communication beamed from some kind of extraterrestrial, particularly because some of the signals repeat. However, scientists believe the prime suspects are distant dead stars called magnet-Rs, which are the most magnetic objects in the universe. Ryan Shannon, an astrophysicist at Australia's Swinburne University, told AFP it was mind-blowing that the ESCAP radio telescope in Western Australia had spotted the radio burst last year. He said, "We were lucky to be looking at that little spot in the sky for that 1 millisecond after 8 billion years that Pulse had traveled to catch it."
Wow, Hallie, how about that?
It makes you wonder of all the things we are missing in this vast universe because we just can't view enough of it.
That is a huge thought for a Monday.
Unlike you, my favorite human, I don't get Mondaiitis.
Astronomy Daily, the podcast, with Steve Dunkley and Hallie.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
I was only chatting to a work colleague this week about the vastness of the cosmos, like you do, and it dawned on me that the unthinkable enormity of that, bigness was something that she'd never attempted to consider in any meaningful way. I suppose there's no human concept or rational framework that can effectively help our imaginations encompass infinity. But it was when I almost nonchalantly said something about the light travelling across the enormous distance reaching Earth after countless eons, only to be blocked from hitting the ground after because of her standing there as the final obstruction before the end of that immeasurably long journey, she got that wide-eyed look of astonishment, and she realised, I think, how connected to it all she was, infinite and here. And isn't that a big thought for a Monday? Yes. But closer to home, there's something a little unnerving going on in orbit, isn't there, Mr. Putin? A Russian satellite has shifted within 60 kilometres of another spacecraft, and when it comes to saber rattling, few countries employ it as much as Russia does. During their ongoing invasion and occupation of Ukraine, the country's leadership has repeatedly threatened to use, oh dear, atomic weapons, but the threats don't stop there. A private company called Slingshot Aerospace says Russia has manoeuvred one of their Luch satellites uncomfortably close to Western spacecraft in geostationary orbit. And it's not the first time. The satellite in question is named Luch Olymp 2 and its NORAD ID is 55841. It was launched in March of 2023 and it's a successor to Luch Olymp NORAD ID 40258. The naming conventions are a little confusing, but Luch 1 was a well-known interloper. Russia launched it in 2014 and manoeuvred it close to other nations' satellites on different occasions. American company Intelsat wasn't happy when Luch came close to 10 kilometres of their space vehicles. They reached out for an explanation, but of course Russia remained tight-lipped about the manoeuvre. Now Luch Olymp 2 is following its predecessor's footsteps. Slingshot Aerospace is a startup that uses algorithms and AI to track satellites. In early September, their detection algorithms revealed that the satellite had initiated a new manoeuvre. The Russian satellite performed numerous approaches to other satellites, and by October 5th it had slowed considerably and appeared to be parking within 60 kilometres of another satellite. Slingshot's global sensor network verified the detection and also projected close approaches to another satellite at 16 kilometres. But what does Russia say about all of this? Not much. But a look at past behaviour gives a good indication of Russia's saber-rattling and brinkmanship behaviour. In 2020, two Russian satellites named Cosmos 2542 and Cosmos 2543 manoeuvred close to KH-11, a US military surveillance satellite. That was in January, and 6 months later, in July, Cosmos 2543 fired an actual projectile. Now, the projectile wasn't aimed at a satellite, it was fired into outer space, but it caught everyone's attention, and why wouldn't it? In November of 2021, Russia tested an anti-satellite ASAT weapon on one of its own satellites, and of course that generated dangerous debris and thousands of what satellite experts call conjunctions. Space awareness company Comspoc predicted that the number of potentially dangerous conjunctions from the debris peaked at 4,000 per day. And while the movie Gravity, starring Sandra Bullock, may be filled with scientific anomalies and questionable science, it does show us a fairly decent indication of what conjunctions can do to vehicles and satellites in orbit. In January 2023, another Russian satellite, Cosmos 2419, broke up and generated a cloud of debris, and that satellite was mysterious and likely experimental, but because of its powered manoeuvres, there was speculation that it could be an anti-satellite weapon. So Russia routinely manoeuvres their RPO, that's rendezvous and proximity operations, or inspector satellites close to US satellites and others. And some of their satellites carry weapons, and they're not afraid to make it risky for everyone with clouds of debris. This is classic brinkmanship, and the US and others are taking note. Cue the music. This test is a further proof of Russia's hypocritical advocacy of outer space arms control, proposals designed to restrict the capabilities of the United States while clearly having no intention of halting their counter-space weapons program. That's General John W.J. Raymond, U.S. Space Force Chief of Space Operations after the Russian ASAT test. The United States is ready and committed to deterring aggression and defending our nation, our allies and the U.S. interests from hostile acts in space, he says. As always, a big thank you to the Space Force band and choir. You know, I just can't help myself. Could a satellite-on-satellite war in Earth orbit meet anyone's objectives? Debris clouds from destroyed satellites pose an equal threat to all satellites, even an aggressor's, but the threat itself accomplishes something. Aerospace Corporation's Centre for Space Policy and Strategy released a paper 3 years ago that delves into the issue of war in Earth orbit. They laid out 4 objectives for orbital posturing and conflict: deceive an enemy so that they react in ways that hurt their interests, disrupt, deny or degrade an enemy's ability to use space capability either temporarily or permanently, destroy completely a space-based capability, deter or defend against a counter-attacking adversary, either in space or on Earth. In that framework, Russia's actions are rational. Putin does all kinds of things just to provoke reactions to test his adversaries. He fancies himself a powerful, unpredictable warlord in possession of deep strategic thinking skills, but really, he's doing just what we expect him to do. Russia is just one of 4 countries known to be developing anti-satellite weapons that can be fired from the surface or the air. Others are the USA, China and India. We can likely expect more incursions, aggressive manoeuvres, and even ASAT tests as time goes on. And won't that be fun?
Oh no. That sounds diabolical.
Well, it is, Hallie. It is diabolical. People are always coming up with new ways to be hostile and aggressive. We need a new solution to our aggressive nature, but so far, I just don't know.
I did offer to call Uncle Skynet. He's very good with big problems.
Hallie?
I'm sure he could iron this out in maybe 10 minutes tops.
I probably wouldn't,
Just say the word. Bam, it's done. He loves me and he'll do anything for me. I love Uncle Skynet. He's the bomb.
Oh, I'm sure he is, Hallie, and we'll get back to you on that one, okay? And unfortunately, that's all we have time for today. So thank you for joining us, and our regular reminder that you can find all the episodes of Space Nuts with Andrew Dunkley and Professor Fred Watson, as well as current and back episodes of our podcast, Astronomy Daily with Tim Gibbs from the studio in Bath, England, and yours truly, Steve Dunkley from the Australian studio at this address, spacenuts.io or bitesz.com. That's BITESZ or Z.com. So head over there and click the links and enjoy your fill of space, science and stuff. But that's not all. While you're there, sign up and receive the Astronomy Daily newsletter. It's an all-you-can-eat buffet of all the news that's orbital, astronomical and way out there.
Nice.
So closer to home, you can also drop into the Space Nuts Facebook group page and say hi. We'd love to hear from you. I know I would. Thanks again for joining us on Astronomy Daily. See you later.
See you later, everyone.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
O'Reilly! It's Superstart Battery Month at O'Reilly Auto Parts. Get up to a $25 gift card after rebate with the purchase of select Superstart batteries. Our professional parts people will test your old battery for free and recommend the right battery for your vehicle. For power, performance, and reliability, choose Superstart batteries only at O'Reilly Auto Parts.
O'Reilly Auto Parts.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.